Welcome back. We are still on projectile motion. Right now, I want to explain everything about a velocity time graph or a velocity versus time graph. So, what is a velocity versus time graph? It's a graph in physics where we are experimenting the velocity of a certain object over the time, and sorry about that. If you check the videos I posted on momentum, you will see a certain video where I explain what to look for when you analyze graphs. And yeah, I recommend you to check that video out. I said that the first thing they put is on the y-axis, and the second thing that they put is on the x-axis. So it's y versus x graph. Let's discuss these types of graphs here. On the first one, let's imagine that we are on top of a building like this here, and there is a ball there. Let's say it's a stone. This stone here, we release that stone. When we release that stone, it will go downwards to the ground. Let's say this is the ground, and then it will hit the ground and stop. So how do we draw a velocity time graph for this? Of course, when we say something is dropped or released, it means that its initial velocity is 0. So when we drop something or when we release something, its initial velocity is 0. So let's choose upwards as positive. When we choose upwards as positive, it means that our gradient, I don't want to talk ahead of myself. Let's discuss this here. Let's discuss the area and the slope before we can discuss what's going on here. And what does the area, let me use a pencil. What does the area of a velocity time graph tell us? It tells us here we have the height is changing velocity because we have final velocity minus initial velocity. So we have the change in velocity, and our base is change in time. So we can put change in time here because it's the final time minus the initial time. So we call it a change in time. So when we calculate the area of a triangle, we say area is equals to, I know most of you know this, is half base times height. But what is our base? Our base is changing time times changing velocity. So what is changing times changing velocity? If you remember the grade 10 formulas, we say that the distance an object travels is its velocity times time. So if you are traveling at a velocity of 5 meters per second in 1 second, then what is the distance that we will cover? Of course, we'll cover 5 meters because it's 5 times 1. So we'll cover a distance of 5 meters in 1 second. That's why it says 5 meters per second. So let's look at the gradient of this line here. What does the gradient of this line tell us? How do we calculate gradient? Remember that the area tells us about the displacement. I know someone is saying distance. Remember that here it can be negative. If you choose downwards as positive, then the graph is going to be like this. If you calculate the distance, you'll find that it is negative, and distance can never be negative. So we call this the displacement. The displacement can be positive and negative, and distance can only be positive. So what else can we do about this graph? Let's calculate the slope. We know that the gradient is equals to change in y over change in x is equals to, what is our change in y? Our change in y is change in velocity over the change in time. What is this formula for? Of course, it's acceleration. So the slope of this tells us about the acceleration. You will finish this with, and what acceleration exactly? It tells us about the acceleration due to gravity, which is always 9.8 meters per second. It does not change, it's always 9.8 meters per second. And yeah, you can go back here. If we throw if we drop a stone from this building here, that stone will have an initial velocity of 0. Here it tells us about the initial velocity. We have initial velocity of 0, and its speed will increase because gravity wants it down, and it also goes down. That's why here we have a positive slope. A positive slope means that our direction of motion matches the direction of gravity. That's why I have a positive slope here. And then what does T3 tell us here? T3 tells us that the stone landed on the ground at T3. So the most common mistake that students do when they are asked to draw the graph is this here. This is a common mistake, and you may get penalized for it. They show this arrow here. What does this arrow mean? It means that this graph here is still continuing. If it is still continuing, that means this stone is still falling, but it's on the ground. So please do not show these arrows here. Any graph you draw in physical science, either chemistry or physics, please do not show arrows. You only show arrows in mathematics. But here, the arrows tells us that the motion of this is still continuing, whereas in real life it has stopped. So T3 tells us that it stopped moving. So that's why we do not show arrow here. And what other thing? And yeah, I think you might get the idea for now. If they say calculate acceleration, you use the slope. If they say calculate the displacement or maximum height, you use this here, the area formula there. Let's look at graph B. I will tell you why it's a straight line. So we can associate graph B with this here. Let's say we are on a building. There's a stone. We throw the stone upwards with a velocity v. What will happen to the stone? The stone, of course, will go upwards and then reach its maximum height here, and then it will return to where it was thrown, and then it will continue falling until it reaches the ground. So let's discuss what's happening here. When the stone is going upwards, its velocity decreases, which is of course what we see here. Let's say here was 10, then it will be 10, 9, 8, up to 0. So when we reach T1 here is when we reach our maximum height. So this here tells us the time that we reach our maximum height. And this here tells us the time that the stone returns to where it was thrown. You can see there, if the stone